In some cases, you're not going to solve for x as the variable. Sometimes they're going to give you a specific variable. And to solve a quadratic equation for a specific variable, we normally apply the square property or the quadratic formula, but you have to first identify which one's your variable from the problem. And remember to use positive or negative when taking square roots. In this example, we are going to solve for d, and a equals pi times d squared divided by 4. Because I want to solve for d, I would like to first rewrite my equation in a way that I can have either the quadratic formula or the square root property, whether I can apply the quadratic formula or the square root property. It looks like I can solve for d squared equals, and then I will be able to apply the square root property. I'm going to multiply both sides by 4. So I can reduce that 4. Now I have 4a equals pi times d squared. And please don't worry about having other letters, other variables. We don't care about them. We're going to treat them as if they were a number. Think of it as if it was 4, 5, 7, any number. So if instead of thinking of you multiplying 4 times a, think as if you were multiplying 4 and 3. But in this case, we're going to put them next to each other because we have a variable and we cannot combine. Then I'm going to divide both sides by pi as if it was a number. On the left side, on the right side, it will reduce. And now I can rewrite my expression as d squared equals 4a over pi. As per the square root property, remember when you have x squared equals k, you have, that's a solution set, x is equal to plus or minus the square root of k. That's what I'm going to try to do here. I'm going to say d is equal to the positive and negative square root of 4a divided by pi. If there's something you can simplify, you can do so. If not, you can leave it as it is. But because I'm the teacher, I need to show you how to simplify your solution all the way to the end. Let me erase all the work that I did up to this point. And I'm going to focus on my answer right now. I'm going to use the simplifying radicals property that we reviewed at the beginning of this chapter. And now I have d is equal to positive and negative the square root of 4a divided by the square root of pi. On the numerator, now we will have the square root of 4 times the square root of a. I hope you remember this. The square root of 4 times the square root of a, which simplifies to 2 square root of a. Let me put it as we have it. Okay, and now when we have a rational expression or a rational term on a radical expression or a radical term, meaning a root. When you have a square root in the denominator, we don't like to have square roots in the denominator, and we have to rationalize. If you need some help on rationalizing, please look for material online on how to rationalize. It's not hard, but I just want you to know what happens. For rationalizing, we're going to multiply both the numerator and the denominator by the square root of pi, because this number right here, the square root of pi divided by the square root of pi, is 1. So in essence, we're multiplying this times 1 so we can reduce our square root on the denominator. Now I have 2 square root of a times the square root of pi divided by the square root of pi squared. The square root cancels with the power, and now I can combine my solution on the numerator. These two, I cannot simplify anything, so I rather have them together as the square root of a times pi. And my final solution is 2 square root of a times pi divided by pi. Please, if you need to rewatch this video a few more times, do so. I understand that the variables can be confusing because instead of working with numbers, we have a and pi. But once you get to this point, once you get to here, everything else is simplifying and reducing and applying properties of radicals, or like the rationalizing and simplifying. But this up to here, we already applied the square root property and we already solved for D.